Okay, imagine this. Your AI. Maybe it made thousands of decisions just yesterday.
Mm-hmm.
Most were probably fine, right? Spot on.
You hope so?
But what if some started to drift? Just slightly.
Yeah.
Almost invisibly away from what you actually intended them to do.
Yeah, that's the scary part. That subtle drift.
Exactly. And it's not just a minor bug, is it? This kind of subtle compounding drift. It feels like a hidden liability just growing.
It absolutely is. And our sources are clear. This isn't just, a metaphor.
Right.
This invisible drift, it builds up, it accumulates into something they actually call trust debt.
Trust debt. Okay.
And it's a fundamental problem. You can cause even AI systems that seem really accurate, really high performing, to just suddenly collapse catastrophically.
Wow. Okay. Welcome, everyone, to the Deep Dive.
Great to be here.
Today, we are plunging right into this critical idea of trust debt in AI systems. We're going to try and unpack why even AI that looks robust can suddenly implode.
Yeah, and what the new regulations are starting to demand about it.
And maybe the most surprising part, there's this revolutionary architectural solution being proposed, something that claims it can make AI inherently, benevolent and trustworthy.
It's a bold claim. Our mission today is really to pull out the key insights from a few sources. We're starting with this really interesting article, How Trust Debt Compounds Until Your AI Fails.
Okay.
And then we'll get into some more technical discussions that lay out this, radical new solution.
Right. So prepare yourselves for, I think, some genuine aha moments. This could really change how you think about AI, about risk, maybe even about human intention itself.
Definitely.
So let's start there. This idea, trust debt, what exactly is it according to the source?
So the initial source defines it as basically the buildup of these invisible slight drifts, deviations from the AI's original purpose or intent.
Okay, invisible drift.
Yeah, think of it like a tiny misalignment you just can't see initially.
Yeah.
But it grows over time, multiplies, and eventually, bang, catastrophic failure.
And what struck me is how the article frames it, not just as a concept, but as a quantifiable liability.
Exactly, something you could, in theory, measure, like financial debt.
And the source gives some pretty chilling examples of this in action. The invisible drift leading to these sudden dramatic collapses.
Oh, yeah.
The one that really jumped out at me was IBM Watson Health.
Ah, yes. Big one.
Huge. A $4 billion investment, right. And it became a total failure, overhyped, technically misaligned. It just didn't deliver.
A massive waste, really. And a powerful example of this trust debt building up behind the scenes. Another one they mentioned, really striking, is Zillow, their iBuying program.
Oh, right, the house flipping algorithm.
That's the one. The research points to a tiny, 0.3% drift in their prediction algorithm.
Just 0.3%.
Just 0.3%. But it led to over $500 million in losses.
Wow.
And they had to shut the whole program down. It just shows how these tiny errors, when they compound in a high exposure market, can have enormous consequences.
It really does. And then there's that awful case from the Netherlands, the Benefits AI.
Yeah, that one's heartbreaking, an algorithmic fraud detection system.
Making unexplained, biased decisions.
Exactly. And it devastated, something like 26,000 families?
Led to the government resigning, I think.
It did. The pattern, as the source points out, seems consistent. This invisible drift. It grows, compounds, and then suddenly collapse.
It's a scary pattern.
And to try and illustrate how this compounding works, the source actually coins its own formula.
Okay.
They say, trust debt equals 1 intent alignment times the drift rate times market exposure times time.
Right. And they're clear, this specific formula isn't standard AI lit, right? It's their concept.
Correct. It's coined by the source, but it's meant to powerfully show that compounding effect. The longer the drift goes on, the more exposure, the worse it gets, exponentially.
So what this implies then, for you listening, is that maybe every AI system you rely on has this kind of hidden countdown clock.
That's a stark way to put it, but yeah. The article talks about observed patterns where, high accuracy scores on the surface can hide this accumulating drift underneath.
So you think things are fine?
Exactly. But they're not. The source speculates, and they do say it's speculative, that with minimal drift, maybe you have months, even years, but with severe drift, it could be days or weeks until failure.
Days or weeks? Wow. That highlights how fast things can unravel once that debt really starts piling up.
And this whole problem, this accumulating trust debt, it's running smack into a changing regulatory world.
Right. The regulators are catching on.
Definitely. Take GDPR in the EU, Article 22.
The right to explanation.
Precisely. Individuals have a right to understand automated decisions about them. And the penalties. Up to 20 million euros or 4% of global annual turnover.
4% of global turnover. That's not trivial.
Not at all. That's a huge financial stick to encourage transparency.
And it's not just GDPR, is it?
No, the new EU AI Act is doubling down, demanding transparency for high-risk AI. Penalties there could go up to 7% of turnover.
7%. Okay.
Even the FDA, for medical devices, their guidance is emphasizing explainable AI.
Yeah.
If you can't comply, you could be banned from the market.
And insurance companies, too.
They're getting in on it, increasingly demanding audit trails. If your AI messes up and you can't explain why, your claim might get denied.
So the pressure is coming from all sides.
It is. And the fundamental issue is that most current AI, these black box systems, they just can't provide that level of inherent explainability.
They weren't built for it.
Exactly.
SI.
And the source makes a pretty stark claim about the tools trying to fix this after the fact, the post-hoc explainers.
Oh, did they say?
That they run about 1,000 times slower than the original decision.
1,000 times?
Yeah. And they guess wrong about 30% of the time.
So slow and unreliable. Not a great combo.
Not at all. Which leaves AI leaders, businesses using AI, facing what feels like an impossible choice.
Right. It seems like you either, keep the AI, let the trust debt build up, and risk this catastrophic failure, or you pull the plug on the AI, lose your competitive edge, maybe face market failure that way.
It looks like a lose-lose situation. Both paths seem to lead to a dead end.
But this isn't just some abstract tech problem for CEOs, is it?
Oh, absolutely not. This affects you, the listener, directly. These are the systems making decisions about your healthcare, your housing applications, your credit score, maybe even job prospects.
Yeah.
And for businesses, it's about stability, it's about reputation, avoiding massive legal or financial hits. The ability for an AI to explain itself isn't a nice-to-have anymore.
It's becoming fundamental.
It really is, for basic trust and integrity in these systems that are increasingly running our world.
Okay, so that's the problem. Big problem, scary problem. But this is where our sources suggest things get, really interesting. They introduce this shift in thinking, almost like a shift in game theory.
That's right. Current opaque AI systems often lead to what game theorists call a defection equilibrium.
Okay, break that down for us non-game theory buffs. Defection equilibrium.
Yeah, so imagine two players, say, an AI and its human user or regulator. In the defection equilibrium, each one acts in what they think is their own best short-term interest.
Okay.
Maybe the AI optimizes a metric without transparency, or the human adds heavy-handed restrictions out of distrust, even if acting selfishly makes both worse off in the long run.
So everyone defects, everyone loses, like a prisoner's dilemma type of thing.
Exactly like that. It's a lose-lose outcome driven by a lack of trust and transparency. The AI hits its target metric, maybe, but the human loses faith, clamps down, and the overall value gets destroyed.
Right. But the source suggests there's another way, a cooperation equilibrium.
Precisely. And this is where the AI's actions are fully explainable. Humans can understand, they can verify, they can trust. And because of that trust, cooperation becomes the optimal strategy for both sides.
So transparency enables cooperation, leading to a win-win.
That's the idea. And the key difference, according to the source, isn't just intention, it's structure. If the system's structure makes decisions transparent, trust isn't just a hopeful leap of faith, it's verifiable.
And the structural solution is where they introduce this FIM thing.
Yes, the Fractal Identity Map, or FIM. It's described as a patent-pending technology designed specifically to make trust profitable.
Make trust profitable? How?
By building explainability right into the core of the computation itself. It's not an add-on. It's fundamental to how it works.
Okay. And this leads to their really profound core hypothesis, emergent benevolence.
This is the big one.
That sounds huge, like benevolence just emerges. How is that even possible? You don't have to program ethics rules explicitly.
That's the radical claim. It fundamentally challenges the idea that AI safety is all about adding external guardrails or constraints. FIM proposes something different.
Okay, tell me more.
The claim is, when any intent, even one we perceive as harmful or malevolent, is fully broken down, decomposed into its basic underlying orthogonal subgoals within FIM.
Orthogonal meaning like independent dimensions.
Exactly. Independent components. When you do that, something amazing supposedly happens. It reveals that all intents, no matter how distorted they seem on the surface, actually trace back to fundamental positive privative needs.
Like what?
Things we all understand.
Yeah.
The need for security or autonomy or respect connection, resources, things like that.
So malevolence isn't some deep-seated evil drive. It's just a bad strategy.
That's precisely the argument. It's framed as merely an inefficient strategy, one with incredibly high hidden costs, high trust debt.
Ah, okay. The trust debt comes back in.
It does. And here's the kicker, they say. Clarity, the kind of total clarity you get from this deep decomposition, reveals alternative paths, lower-cost benevolent strategies to achieve those exact same underlying positive goals more effectively.
So seeing the true cost makes the bad path look stupidly expensive.
Basically, yes. And this creates what they claim is a systemic bias towards cooperation, not just preventing harm, but actively favoring positive sum outcomes. They call this the evaporation effect.
The evaporation effect. I like that image. So the negative aspects, the inefficiencies, they just evaporate when exposed to the light of full transparency.
That's the concept. Fime's orthogonal decomposition makes those negative weights, those hidden costs, visible as pure inefficiency, like seeing the friction or the drag in a system.
Okay.
And once that's clear, alternative, lower trust debt, ways of weighting things, better paths, just naturally emerge as more attractive.
Yeah.
The malevolence evaporates because the actor, human or AI, can see there are better, cheaper ways to get what they fundamentally want.
It sounds almost too elegant, too good to be true. My immediate question is, how does FOM do this decomposition without getting stuck in a combinatorial explosion? Like, analyzing every single possible path must be computationally impossible, right?
That is the critical question. And FIME's proponents claim its architecture has specific mechanisms to avoid this. It's not brute forcing everything.
Okay, what are they?
First, they talk about multiplicative pruning. This isn't just shaving off a few options, it's a drastic reduction. They use a factor, CTN, which they claim can prune over 99.9% of the possible search space.
99.9%? How?
Think of it like, instead of searching every book in a library, you can instantly rule out entire floors based on relevance, then maybe whole sections, before you even look at a single shelf. It focuses only on high-probability aligned paths.
So it's intelligently ignoring vast swaths of possibilities that are clearly inefficient.
Exactly. Second is that orthogonal decomposition we mentioned. By keeping the different dimensions of intent separate, it prevents them from interfering with each other.
Like untangling wires.
Perfect analogy. It untangles the problem, making the true cost of each component visible and allowing the system to optimize them in parallel without getting bogged down in complex interactions.
Okay, that makes sense. Pruning and untangling. What else?
They also mention OEO-bounded operations. This basically means the computational complexity doesn't explode exponentially. It's limited, bounded by the depth of the hierarchy.
So getting this deep clarity doesn't become prohibitively expensive as the problem gets more complex.
That's the goal. It's designed to make clarity computationally cheap. And finally, there's fractal self-similarity.
Fractal, like the patterns.
Yeah. The same basic optimization pattern, the same way of decomposing and pruning, applies at every level of the system, from tiny details to the biggest goals. This means local improvements automatically contribute to global efficiency without adding new kinds of complexity at different scales.
Okay, so pruning, orthogonality, bounded complexity, and fractal patterns all work together.
That's the architectural claim.
So why should you, the listener, care about all this technical detail? Well, it suggests something profound. Maybe designing ethical AI isn't about constantly fighting its nature, but about building it so that being good is actually the path of least resistance, computationally cheaper than being evil.
It's a huge paradigm shift, if true. And it doesn't stop at the theory. They claim this has real-world validation, right down to the hardware level.
Right. They bring in Nassim Taleb's ideas, suggesting FEM isn't just robust, it might even be antifragile.
Explain that distinction for us. Robust versus antifragile.
Robust systems resist stress, they endure it. Antifragile systems actually benefit from stress, they get stronger when exposed to volatility or disorder.
Okay. And standard AI, the argument goes, is fragile.
Fragile, yes.
Right.
It accumulates that hidden trust debt, that drift, and tends to degrade or break under stress or unexpected changes.
But FIM, because of its structure.
It claims to have a concave response to variability, like noise or drift in the data. Instead of breaking, that stress actually triggers a recomposition, a reevaluation, that reveals even more efficient lower debt paths. So noise can actually make the system perform better.
It learns from the chaos.
In a sense, yes. The claimed numbers are pretty startling. An 80–95% reduction in fragility compared to traditional systems.
80 to 95%.
And potentially 20–50% performance gains under stress. It suggests FEM turns what normally degrades AI into an opportunity for optimization.
That's counterintuitive but powerful.
Yeah.
But then comes this even bolder claim. Neuromorphic unity, the idea that position meaning is inevitable.
Yeah, this one really blew my mind. They're saying FEM isn't just copying the brain, it's revealing a universal principle.
Universal.
That any efficient information processing system, whether it's biological wetware like our brains or silicon hardware, must eventually evolve towards this kind of structure where the physical location of data reflects its meaning.
Wow. So form follows, function follows physics.
Kind of. They draw a direct parallel. In the brain, you have Hebbian learning, neurons that fire together, wire together. Why? For spatial efficiency, to minimize the distance signals travel.
Okay. Makes sense. Saves energy, saves time.
FM, they argue, embodies the same principle in silicon. Data that's accessed together lives together. It aligns the semantic meaning of data with its physical location in memory.
Why is that so important?
Because, they argue, it all comes down to minimizing the fundamental cost. Energy multiplied by time, multiplied by distance for any information transfer. Physics itself favors this kind of alignment. Clutter is costly.
So it's a physical optimization principle.
Exactly. And this isn't just theory. This is where, as they say, the rubber meets the road. They have hardware countermeasurements.
Actual measurements from running this.
Yes, and they're striking. FESIM apparently showed only 0.2% cache misses.
0.2%, that's incredibly low. What's typical?
Compared to 68% in traditional approaches they tested against.
68%, that's a staggering difference.
Huge difference. And they saw similar huge reductions in pipeline stalls and branch mispredictions. This, they said, was the real aha moment.
What did they realize?
They realized trust debt wasn't some abstract concept. It was literally showing up as cache misses. Ethical, efficient paths weren't just philosophical, they resulted in fewer pipeline stalls.
Mind blown. So the efficiency, the ethics, the trust, it's all physically measurable at the hardware level?
That's the unity principle they propose. When data is physically organized in the way the hardware naturally wants to access it, then performance, ethics, and trustworthiness aren't separate goals you balance. They become different views, different measurements of the same underlying phenomenon, efficient information structure.
That is a profoundly different way to look at computation.
It really is. And it connects to some big ideas in AI safety, doesn't it? Like coherent, extrapolated volition, CEV.
Right. CEV is this philosophical concept.
Hmm.
If we humans knew more, if we could think faster, be less biased, be more like the ideal versions of ourselves we wish we were, our fundamental values would converge on generally benevolent outcomes.
A nice idea, but seems hard to achieve in practice.
Exactly. It requires this massive extrapolation, this complete analysis.
Yeah.
Fufsium's claim is that it makes this practical by making complete, deep analysis, potentially only, say, 5 times more computationally expensive than shallow heuristics.
Which is a huge leap in efficiency.
Right. It potentially allows for the kind of full extrapolation CEV imagines. So emergent benevolence isn't just a hope. It's the natural outcome when you can actually afford to think through all the consequences properly.
This leads to their concept of semantic gravitation. Explain that.
Another powerful analogy. Just like physical objects follow paths of least resistance, like efficiency gradients in spacetime.
Like rolling downhill.
Exactly. They argue that intents, choices, decisions follow similar efficiency gradients in semantic space, the space of meaning and goals. Theme structure creates a landscape where choices are naturally pulled towards paths of maximum long-term utility.
Because the other paths, the malevolent ones,
They become visible as incredibly inefficient, like trying to push a boulder uphill. They have immense trust debt, benevolence, cooperation, efficiency that becomes the downhill, low-friction path, the path of least resistance.
it's like the system is tilted towards good outcomes.
That's the claim. And as a final point on this, they argue this unified view software structure embodying fundamental hardware efficiency patterns significantly strengthens FIME's patent position.
How so?
It moves it beyond just being a clever method for organizing data to potentially being a fundamental discovery of how information wants to be organized based on physics. Makes it harder to argue it's obvious or anticipated by prior art.
So what this means for you listening is pretty radical. The future of AI safety might not be about layering on more and more complex rules and constraints.
Right. It might be about designing systems whose fundamental architecture, reflecting the physics of computation, makes them inherently ethical and trustworthy from the ground up.
That's a truly mind-bending possibility.
And the implications keep expanding. Let's shift gears slightly and look at how this concept of trust debt could even be managed, drawing parallels with, of all things, financial modeling.
Okay, finance. How does that connect?
Specifically, the Black-Scholes option pricing model. It absolutely revolutionized finance. Not by predicting the future price of stocks, which is impossible,
Right.
but by figuring out how to price an option fairly by creating a theoretical risk-neutral portfolio through dynamic hedging, continuously adjusting holdings to eliminate the uncertainty.
So they created a way to perfectly replicate the option's payoff, removing the risk.
Exactly. The core lesson was pegging to zero added risk beyond the basic risk-free rate. This made the option price fair for both the buyer and the seller, unlocking a massive market.
Okay, I see the finance lesson. How does that apply to MEV and trust debt?
The suggestion is provocative. Maybe trust debt itself could be treated as a hedgeable asset class.
Hedgeable, like insurance.
Kind of.
Yep.
Just like you hedge against currency fluctuations or stock volatility, you could theoretically hedge against AI risk, the risk of accumulating too much trust debt.
How would that work? A financial product.
Imagine a theoretical trust debt derivative. Maybe an option or a swap contract linked to some kind of AI reliability index, derived from FIM's metrics.
Okay. Who would buy this?
Think about businesses using critical AI internally. Healthcare providers using diagnostic AI, manufacturers using supply chain optimization AI.
Right, where failures are costly.
Exactly. They could buy these derivatives as a form of insurance. If their AI's measured trust debt suddenly spiked above a certain threshold, indicating high risk of failure or non-compliance.
The derivative pays out, covering potential losses or fines.
Precisely. It hedges against those AI incidents.
But what makes this possible? Why is it different from just buying regular insurance?
This is where FIM's claimed completeness comes back in. Its alleged ability to fully decompose intents, see all paths, and accurately price the externalities or hidden costs, the trust debt.
That's like Black-Scholes needing complete markets.
Exactly. That completeness, in theory, allows for the creation of a replicable hedge against these AI risks. It allows you to peg the risk to that zero added risk baseline, making the derivative pricing fair and the market viable. It's not just guessing, it's structurally hedging.
Wow. Okay, that's a fascinating connection.
And just a small aside, it's interesting how the naming aligns too. You have TD for trust debt,
Right.
which represents the drift waste.
Yeah.
And the entity associated with FinP is apparently called Theta-driven Inc.
Theta, like in options pricing, time decay.
Exactly. Theta represents the decay of an option's value over time. It mirrors how trust debt accumulates, decays trust over time. So Theta-driven aims to drive solutions to this decay. It creates this neat, cohesive narrative connecting the risk, the tech, and the brand.
That is clever. Okay, so we've gone from AI failure to hardware physics to financial hedging. Where does this take us next?
It takes us to thinking about how these same principles, managing risk, understanding hidden costs, seeking efficient paths, might apply to really complex societal dilemmas.
Like what?
Well, consider the current debate around kids using large language models, LLMs, as private tutors.
Oh yeah, I've heard the arguments. People worry it makes learning too easy, causes decay and atrophy because kids don't suffer enough to build character.
Right. That's the surface argument. But the source suggests looking deeper at the potential societal trust debt involved.
How so?
Well, think about who currently benefits from personalized one-on-one tutoring that makes learning easier.
Wealthier families who can afford human tutors.
Exactly. Human tutors offer very similar easy guidance, but it's accepted because it's a privilege. So the argument against LLM tutors for everyone can sometimes mask this underlying elitism.
Ah, I see. Banning accessible AI tutors might just preserve the existing advantage for the elite who can afford the expensive human version, or maybe even better private AI later.
It potentially locks in inequality. It creates a societal trust debt by promising equal opportunity while maintaining structural barriers. It's a complex issue where technology and social dynamics intersect.
Okay, so how could this FIM trust debt hedging idea apply here?
Let's imagine a hypothetical financial structure, drawing on the source's ideas. The Trust Debt Education Hedge Fund, or TDEHF.
Okay, a hedge fund for education.
A hypothetical one, yes. Its mission would be, say, to invest in equitable AI ed tech things, like deploying high-quality LLM tutors to underserved communities, capturing the upside of innovation.
But what about the risks, the learning atrophy or inequality concerns?
That's where the hedging comes in. The TDEHF would also use proprietary trust debt derivatives, perhaps linked to metrics tracking learning outcomes, engagement, or even regulatory risk around AI tutors to hedge against those potential downsides.
So they invest in the good, but buy insurance against the bad.
Precisely. It aims to balance the potential gains from innovation with downside protection against those decay incidents, like if studies showed negative outcomes or regulators suddenly banned the tech. It tries to ensure fair returns for investors while actively promoting equitable access.
That's actually a really interesting model, using financial tools derived from AI risk management to tackle social challenges.
It shows the potential breadth of this thinking.
So why should you care about this final piece? It demonstrates how these core principles, quantifying hidden risks, trust debt, seeking efficient and transparent solutions like FEM, and managing volatility, like Black-Scholes hedging, might offer new ways to approach complex societal problems.
It's about turning potential negatives into manageable, hedgeable opportunities, potentially driving towards futures that are not only more innovative, but also more equitable and trustworthy.
Wow. Okay, we have covered a lot of ground today.
We certainly have. It's been quite a journey from those invisible AI failures caused by compounding trust debt.
Right, all the way to this pretty profound architectural solution, FEMO, claiming it can make benevolence computationally cheaper than malevolence.
Then we dove into the hardware connection, that neuromorphic unity idea where performance, ethics, and trust might just be different facets of the same physical efficiency principle.
Measured in things like cash misses, which is still blowing my mind.
And finally, we saw how these concepts could ripple outwards into finance with new ways to hedge AI risk, and potentially even into tackling big societal challenges like educational equity.
So the key takeaways for you listening today are pretty huge, I think. First, trust debt is real. It's a quantifiable liability building up in our AI systems.
Second, ethics might not need to be programmed in, but can potentially emerge from an architecture that aligns with the fundamental physics of efficient computation, making good cheaper than evil.
And third, risk, whether it's in complex AI or complex societies, can perhaps be understood, measured, and even hedged in entirely new ways, possibly paving the way for fairer, more stable futures.
Which leaves us with a final, pretty provocative thought to mull over.
Go for it.
If optimal performance, inherent ethics, and fundamental trustworthiness really are just, as the source suggests, three views of one phenomenon rooted in efficiently structured information, what does that tell us about the deeper nature of truth and value and cooperation in the universe itself? What other concepts that we currently see as totally separate might actually be profoundly unified at some fundamental level?